Hello and welcome. Today, we are exploring a key concept in organic chemistry, diols. You are likely familiar with alcohols, which are molecules containing a hydroxyl, or OH, group. But what happens when a molecule has two of these groups? That is precisely what a diol is, and we are going to break down everything you need to know. A diol is an organic compound that contains two hydroxyl functional groups. The name itself is a perfect clue. The prefix D means two, and the suffix OL signals an alcohol. So, a diol is literally a two-alcohol molecule. A very common example is ethylene glycol, the main ingredient in car antifreeze. Its structure has two carbon atoms, and each carbon has one OH group attached. We classify diols based on the position of these two hydroxyl groups relative to each other. First, we have geminal diols. Geminal comes from the Latin word for twin, which is a great way to remember that in these molecules, both OH groups are attached to the very same carbon atom. This arrangement is often unstable due to steric crowding, and these diols tend to lose a water molecule to form a more stable carbonyl compound. The second, and more common, type is the vicinal diol. Vicinal comes from the Latin for neighbor, meaning the two OH groups are on adjacent carbon atoms, or carbon neighbors. Ethylene glycol is a perfect example of a stable vicinal diol. Naming these compounds follows a simple set of rules. You find the longest carbon chain that includes both OH groups, use the full alkane name, like ethane or propane, and then add the suffix diol. You must also use numbers to indicate which carbons the hydroxyl groups are attached to, such as ethane 1,2-diol or propane 1,3-diol. The presence of two OH groups gives diols unique properties. They can form more hydrogen bonds than a comparable single alcohol molecule, which results in higher boiling points and greater solubility in water. This is why ethylene glycol works so well as antifreeze and why another diol, propylene glycol, is used in food and cosmetics to retain moisture. In summary, diols are versatile and important molecules defined by their two hydroxyl groups, classified by the position of those groups, and named systematically to describe their structure. Thank you so much for watching this video. If you found this explanation clear and helpful, please give it a thumbs up, subscribe for more chemistry content, and hit the notification bell so you don't miss our next video. Your support helps us create more educational content like this. See you in the next one.